Chapter number 1, Force and Motion. Keynote number 1. Any object with mass has the tendency to attract other objects. This force of attraction is called gravity or gravitational force. Center of gravity is the point through which the whole weight of body appears to end.
The stability of body is determined by following. Number 1. Position of central gravity body, which is most stable at bottom. And number 2. Area of base support, which is more stable if base support is broad or flat.
Stable equilibrium. When a body is said to be in stable equilibrium, the body has ability to regain its original position. Second, unstable equilibrium. The body is said to be in unstable equilibrium when the body does not have ability to regain its original position. And at last, we have neutral equilibrium. The body is said to be in neutral equilibrium when the body neither takes new position nor gains its original position.
Key point 4. A pair of equal and parallel force acting in opposite direction is called couple, and turning effect of couple is called moment of couple. Moment of couple is given by torque is equal to F times T, F being force and T being perpendicular distance. Key point 5. Principle of movement states that at stable equilibrium, the counterclockwise moment is equal to clockwise moment. F1 d1 is equal to F2 d2.
Characteristics of free-falling object. Objects falling under the sole influence of gravity is known as free-falling object. Second, it does not encounter with air resistance. Third, it falls under the uniform acceleration rate at 9.8 meters per second squared.
Drag force. Drag force is the air resistance acting on the falling object which opposes the force of gravity, and its mathematical formula is dF is equal to 0.5 times d times velocity square times a times c. So where d stands for density of air, and v stands for velocity, and a stands for surface area of object, and C stands for drag coefficient.
Chapter 2. Pressure and fluid. A pressure is defined as the thrust per unit area. A thrust is a perpendicular force acting on the surface area. So its formula is pressure is equal to thrust divided by area.
Factor influencing the magnitude of pressure due to the solid. Number 1. Magnitude of applied force is directly proportional. As the magnitude of applied force increases, the pressure also increases. Number 2. Contact area is inversely proportional. As the contact surface area increases, the pressure decreases.
A depth inside the fluid and the density of a fluid and acceleration due to gravity are the some factors affecting the fluid pressure.
According to the principle of hydraulic machine, F1 divided F2 is equal A1 divided A2, where A1 and F1 are force applied on smaller piston with area A1, and F2 and A2 are force applied on larger piston with area A2.
Pascal law states that the pressure exerted through a confined liquid is transmitted equally and undiminished in all directions throughout the mass of the liquid. And Pascal law is used in hydraulic machines such as excavators and hydraulic jack.
Work is said to be done only when a body is displaced under the application of force. Mathematical formula is given by W equals to F times T, and the SI unit of work is joules.
Factors determining the work done: magnitude of the force applied, and the displacement of the body, and the angle at which the body is displaced with relation to the direction of the applied force.
It is an amount of work done in a given period of time, and the formula to calculate is power is equal to work done divided by time, and the SI unit for power is joule per second.
Special cases of work done. Maximum work done is when force and displacement are parallel, cos theta is equals to 0. Minimum work done is when force and displacement are perpendicular, cos theta is equals to 90. Energy is defined as capacity to do a work, and there are two types of energy, and they are potential energy and kinetic energy. Potential energy is the energy possessed due to position, and the formula is mgh. And kinetic energy is the energy possessed due to motion, and the formula is half mv squared. Law of conservation of energy states that energy can neither be created nor can be destroyed. It can transfer from one form to another, but the total energy remains constant or same. Example like swinging of pendulum and rolling of ball.
Energy conservation. Energy we consume needs to be conserved because all of the energies are not same and they do not last forever. Some are renewable energy and non-renewable energy. Therefore, sustainable use of energy is very important. Energy can be used efficiently by first, using energy efficient appliances, second, insulating the living rooms, and third, using advanced technologies. There are 5 sources of sustainable energy or renewable energy. They are hydro energy, harnessed from this water. We have solar energy, harnessed from the sun. We have wind energy, harnessed from the wind. Bioenergy, energies which are extracted from biomass such as plants and woods. Then we have geothermal energy, energy which are harnessed from the earth's internal heat.
Specific heat capacity. It is the amount of heat required by a substance to change its temperature by 1 degree Celsius. It is given by C equals to Q divided by M delta T, where C stands for specific heat capacity and Q stands for the amount of heat required, and M stands for the mass of a substance, and delta T stands for change in temperature.
So we know that water has the highest specific heat capacity. So let's look into the applications of the highest specific heat capacity. So the first application, coolant in automobiles. So it is used as coolant in automobiles as it takes a long time to heat and it can absorb a large amount of heat due to its high specific heat capacity. And the second application is hot water bag. So water is also used in hot water bag as it takes a long time to lose heat due to its high specific heat capacity. So the third one, sponging during high fever. During sponging, it can absorb a large amount of heat from our body and lower the temperature of our body due to its high specific heat capacity.
Calorimeter, the device in which two liquids of different temperature are mixed and measure the final temperature is called calorimeter. The principle behind calorimeter is equal to heat gain is equal to heat loss, or MC theta 1 minus theta is equal to MC theta minus theta 2, where theta 1 is equal to temperature of hot body and theta 2 is equal to temperature of cold body, and theta is equal to temperature of mixture.
Latent heat. It is an amount of heat hidden inside our body undetected by a thermometer is called latent heat.
Amount of heat required to change solid state to liquid state by unit mass of substance is called specific latent heat efficiency. The amount of heat required to change from liquid state to vapor state by a unit mass of a substance is called specific heat of vaporization. Thank you.